Welcome back in lecture series on topic electrochemistry. In last video, we have studied Kohlrausch law and its application. And you know that Kohlrausch law is used to calculate the molar conductivity at infinite dilution of strong electrolyte as well as weak electrolyte. And today in this lecture, we will solve numerical problem based on Kohlrausch law of independent migration of ions. So let us see how to solve the numerical problems based on this law. While solving the numerical problem, the most important point, that is, you have to remember this mathematical expression of Kohlrausch law. So lambda 0, that is the molar conductivity at infinite dilution, is equal to n plus lambda 0 plus n minus lambda 0 minus. So lambda 0 is the molar conductivity at infinite dilution or zero concentration. Small lambda 0 plus is the molar conductivity of cation at zero concentration. Small lambda 0 minus is the molar conductivity of anion at zero concentration. N plus indicates number of moles of cation and N minus indicates number of moles of anion in the formula. So this is very important. And another point, that is unit of molar conductivity. Unit of molar conductivity is Siemens centimeter square mole inverse or Ohm inverse centimeter square mole inverse. So these 2 points are very important. Now we will solve the numerical problem. Calculate molar conductivity at zero concentration of magnesium bromide. Molar conductivity at infinite dilution of magnesium ion and bromide ion are 105.8 Ohm inverse centimeter square mole inverse and 78.2 Ohm inverse centimeter square and mole inverse respectively. So what is given? Molar conductivity at infinite dilution of magnesium ion is 105.8 and that of the lambda 0 values of bromide ion is 78.2, and we have to calculate lambda 0 of MgBr2. So according to Kohlrausch law, lambda 0 is equal to n plus lambda 0 plus n minus lambda 0 minus. So first you have to write the ionization reaction or dissociation reaction of the electrolyte. So MgBr2 gives Mg ions plus 2 bromide ion, and therefore the expression for this electrolyte becomes lambda 0 of MgBr2 is equal to lambda 0 of Mg ion plus, here coefficient is 2, that is the 2 moles of Br ions are there in MgBr2, therefore 2 into lambda 0 of bromide ion. Now lambda 0 of Mg ion is 105.8 and lambda 0 of bromide ion is 78.2. So we will substitute these values. Lambda 0 of MgBr2 is equal to 105.8 plus 2 into 78.2. That is equal to lambda 0 of MgBr2 is equal to 105.8 plus this multiplication comes to be 156.4. So that is equal to 262.2. Unit is Ohm inverse centimeter square mole inverse. So lambda 0 of magnesium bromide is 262.2 Ohm inverse centimeter inverse square mole inverse. So here important is, in board exam the unit carries half mark and the correct value of lambda 0 carries half mark, so 1 mark. And here the formula, proper formula with this dissociation reaction carries half mark and substitution of the values carries half mark. So generally for 2 marks such a type of examples are asked in board exam. Now see the another problem. The molar conductivity at zero concentration of the sodium acetate HCl and sodium chloride in ohm inverse centimeter square mole inverse are 90.8, 426.2 and 126.4 respectively. Calculate molar conductivity of acetic acid at zero concentration. Now what is given? Lambda 0 of sodium acetate is 90.8, lambda 0 of HCl is 426.2 and lambda 0 of NaCl is 126.4. And what is asked? Lambda 0 of acetic acid. Now see here, all these three are the strong electrolyte and lambda 0 values of strong electrolyte are given to you. And we have to calculate lambda 0 of acetic acid, that is weak electrolyte. It is one of the application of Kohlrausch law. We can calculate lambda 0 of weak electrolyte from values of strong electrolyte by adding or by subtracting the lambda 0 values of strong electrolyte. Now according to Kohlrausch law, lambda 0 is equal to n plus lambda 0 plus n minus lambda 0 minus. So here lambda, first what you have to write, that is lambda 0 of sodium acetate is equal to lambda 0 of acetate ion plus lambda 0 of sodium ion. Like that, lambda 0 of HCl is equal to lambda 0 of H ion plus lambda 0 of Cl ion. And lambda 0 of NaCl is equal to lambda 0 of Na ions plus lambda 0 of Cl ion. And like that, lambda 0 of acetic acid is equal to what? Lambda 0 of acetate ion plus lambda 0 of hydrogen. Now if you see the expression for acetic acid, then in this expression of acetic acid, Cl ions are not there and sodium ions are not there. So we have to cancel these ions. So see how this is carried out. For that, we have to add first the lambda 0 values of sodium acetate and HCl, and from that we have to subtract lambda 0 value of NaCl. So lambda 0 of acetic acid is equal to lambda 0 of sodium acetate plus lambda 0 of HCl minus lambda 0 of NaCl. So here substitute the value of lambda 0 of expression of lambda 0 of sodium acetate, that is lambda 0 of acetate ion plus lambda 0 of sodium ion. Lambda 0 of HCl is nothing but lambda 0 of the H ion plus lambda 0 of Cl ion minus lambda 0 of sodium ion minus lambda 0 of Cl ion. So here plus lambda 0 of Cl and minus lambda 0 of Cl is cancelled, and plus lambda 0 of Na ions and minus lambda 0 of Na ion is cancelled, and what is remain? Lambda 0 of acetic acid is equal to lambda 0 of acetate ion plus lambda 0 of hydrogen. The values of the lambda 0 of sodium acetate are given 90.8, lambda 0 of HCl is 426.2 and lambda 0 of NaCl is 126.4. So when you substitute these values in this equation, we will get what? 90.8 plus 426.2 minus 126.4, and that is equal to 390.6 ohm inverse centimeter square mole inverse. That is what? The molar conductivity at zero concentration of acetic acid. So like this we can calculate the molar conductivity of any weak electrolyte from strong molar conductivity at infinite dilution, that is lambda 0 values of strong electrolyte. See the same type of problem. Calculate lambda 0 of monochloroacetic acid if lambda 0 values for HCl, KCl and the monochloro potassium acetate are respectively 4.261, 1.499 and 1.132 ohm inverse centimeter square mole inverse. What is given? Lambda 0 of HCl is 4.261, whereas lambda 0 of KCl is 1.499 and lambda 0 of monochloro potassium acetate is 1.132. Kohlrausch law is lambda 0, mathematical expression of Kohlrausch law, lambda 0 is equal to n plus lambda 0 plus n minus lambda 0 minus. So in the same way we have to solve. Lambda 0 of HCl is equal to lambda 0 of H ions plus Cl ion. Lambda 0 of KCl is equal to lambda 0 of K ions plus Cl ion. And lambda 0 of CH2ClCOOK, that is monochloro potassium acetate, is equal to lambda 0 of the monochloro acetate ion plus lambda 0 of potassium ion. And the lambda 0 of monochloro acetic acid is equal to lambda 0 of the monochloro acetate ion plus lambda 0 of hydrogen ion. So here Cl ions are not there and potassium ions are not there. So we have to cancel this. So lambda 0 of monochloro acetic acid is equal to lambda 0 of monochloro acetate ion plus lambda 0 of potassium ion. That is, first you have to add the lambda 0 values of monochloro potassium acetate and the lambda 0 values of HCl, and from that we have to subtract lambda 0 of KCl. So lambda 0 of monochloroacetate ion plus lambda 0 of potassium ion plus lambda 0 of HCl, that is lambda 0 of H ions plus lambda 0 of Cl ion, minus lambda 0 of K ions minus lambda 0 of Cl ion. So plus lambda 0 K plus ion and minus lambda 0 K plus ion cancel, plus and minus, and here plus lambda 0 of Cl ion and minus lambda 0 of Cl ion cancel. What is remain? That is the molar conductivity of monochloroacetic acid is equal to lambda 0 of monochloroacetate ion plus hydrogen ion. What is given here? Lambda 0 of HCl is equal to 4.261, KCl is 1.499 and this monochloro potassium acetate is 1.132. So if you substitute these values, that is lambda 0 values of monochloro potassium acetate, that is 1.132, plus lambda 0 values of HCl, that is 4.261, minus lambda 0 values of KCl, that is 1.499, then it is equal to 3.894 ohm inverse centimeter square mole inverse, and that is what? Molar conductivity at infinite dilution of monochloroacetic acid. So like this you can calculate the molar conductivity at infinite dilution of any weak acid or any weak electrolyte. Now see here, problem number 3. Molar conductivity at infinite dilution of Al2SO4 is 858 Siemens centimeter square mole inverse. Calculate molar conductivity at infinite dilution of aluminium ion. And what is given? Molar conductivity of SO4 ion is given, and that is equal to 160 Siemens centimeter square mole inverse. So what is given? Molar conductivity of electrolyte is given to you, and that is 858 Siemens centimeter square mole inverse. And anion is also given, that is SO4 ion, that is equal to 160 Siemens centimeter square mole inverse. And we have to calculate the molar conductivity at infinite dilution, that is lambda 0 of aluminium ion. Lambda 0 of SO4 ion is given and lambda 0 of aluminum sulfate is given. So according to Kohlrausch law, lambda 0 is equal to the lambda 0 of cation plus lambda 0 of anion. So first you have to write the dissociation reaction. Al2SO4 thrice gives you twice Al ion plus thrice SO4 ion. So this expression for Al2SO4 is Kohlrausch expression for Al2SO4 is lambda 0 of aluminum sulfate is equal to 2 into lambda 0 of aluminum ion, because here in the formula 2 Al ions are there. So 2 into lambda 0 of Al ion plus 3 into lambda 0 of SO4 ion. Lambda 0 of Al2SO4 is 858 and lambda 0 of SO4 ion is 160. So substitute this value. 858 is equal to 2 into lambda 0 of Al ion, which we have to calculate, plus 3 into 160. So that is equal to 858 is equal to 2 into lambda 0 of Al ion plus this multiplication comes 480. So here 2 into lambda 0 of Al ion is equal to 858 minus 480, and that is equal to 2 into lambda 0 of Al ion is equal to 378. That is the molar conductivity at infinite dilution of 2 Al ion. From that we have to calculate the molar conductivity for single Al ion. So lambda 0 of Al ion is equal to 378 divided by 2, and that is equal to 189 Siemens centimeter square mole inverse. That is the lambda 0 of Al ion, that is molar conductivity at infinite dilution of Al ion is equal to 189 Siemens centimeter square mole inverse. So if the molar conductivity of anion is given, electrolyte is given, then you can find out the molar conductivity at infinite dilution, that is lambda 0 value of the cation. So like this you have to solve the numerical problems based on Kohlrausch law. Thank you.